Okay, as I promised you today in class, I want to do a video here on Pascal's triangle. It's going to be really helpful, especially for the next lesson. It's something that sometimes you see it in your algebra classes, sometimes you don't. It's really helpful, like I said, in expanding anything that looks like this, or a minus b to the n power. I'm going to start with plus, though. And so if I had it to the fifth power, it's a way to quickly go to the answer of what I would get if I multiplied this by itself 5 times without actually having to do the box method 5 times over. It gets pretty complicated the further you go. So the first thing to know, like I brought up in class, is you're going to see here that on the outside, all of your items are going to be the number 1. Of course, it's not going to do what I want it to do. There we go. We have 1s on the outside of Pascal's triangle all the way down. This is a shortcut. It is not... There is still always the longhand way you can solve this, which again, the longhand way that most of you know is the box method. So, apologies that apparently my computer's a little bit slower. It's uploading your lesson video right now to YouTube. The next thing to notice here is how we get all the numbers in the middle. So, for any number, you're going to take the 2 numbers that are above it, and you're going to add them together. So 1 plus 1 equals 2. 1 plus 2 equals 3. 35 plus 35 equals 70. 120 plus 210 is 330. So that's the next thing that helps you just set up the triangle. And it's going to be helpful to know how to set up the triangle so you can then use the triangle. That's all there is to the setup. There's no other tricks about the setup. Now, for the actual use, that's going to take a little longer to describe. When I'm using this triangle, what you're going to want to do is you're going to think about this in terms of the row that it's on. So my first row is the n equals 0 row. It's going to be what happens when this n right here is 0. Anything to the 0 power is 1, therefore I'm going to get out a 1 from this. This is going to be my n equals 1 row. So let me actually write this out here. A plus b to the 0 power is 1. A plus b to the first power is going to be 1a plus 1b. My next row will be my n equals 2, which would be a plus b squared, which would be 1a squared plus 2ab plus b squared. Kind of getting tight there. And so on and so forth. Now this one you should be pretty familiar with because we square things all the time. And we get out a squared plus 2ab plus b squared. And I'll go through and I'll show that with multiplying with boxes as well. But what's super handy about this is I can come down here and say, okay, so here's n equals 3, 4, I'm going to go for a tough one, 5, 6, let's do 7. Mostly because I don't want to go too deep because I don't want to spend that much time writing. Again, more laziness than difficulty. What this is saying down here, for my n equals 7th row, which of course is technically the 8th row because the first row is the n equals 0th row. So that is something to remind yourself of. On the n equals 7th row, it means that we're taking the function a plus b to the 7th power. If I'm doing that with boxes, I'm going to have to repeat my process over and over and over and over and over again. It's not that I can't find it, it's just going to take a long time, and we like shortcuts sometimes in math. This is one of the few places where I do like the shortcut. Normally I don't love shortcuts because they sometimes cost you more in confusion than they're worth. But this one will be handy for you. In our next lesson, realistically, we're not going to use it much after this next lesson, but it's one of those things that will pop up randomly in your math classes. A little bit this year, mostly maybe in years to come. And so it's just, Pascal's triangle is a handy tool to have in your back pocket. So what I see here is I'm going to write out my coefficients first in order. The order does matter. You cannot switch the order. Now let's move that one out a little bit further. Okay. So, I'm even going to move that one out just a little bit further than I've got it, just to give myself plenty of space to write. What's going to happen is you're going to take your first term to that highest power, and then the next term to the lowest power it could be. And what's going to happen here is these two powers always need to add up to make your n. In this case, that's 7. And you're always going to start with the first term being the highest thing, the next term being the lowest thing. So here I have a to the 7th, b to the 0th. And what's going to happen is the next term, you're going to decrease the first term's power by 1 and increase the next term's power by 1. So we still have 6 plus 1 equals 7. And I'm going to get 7 a to the 6th, b to the 1st. My next term will be a to the 5th, b squared. A to the 4th, b cubed. A to the 3rd, b to the 4th. A squared, b to the 5th. A to the 1st, b to the 6th, and a to the 0th, b to the 7th. And then at this point I can simplify, because obviously anything to the 0th power is 1, and anything to the first power I can ignore the power. And of course the coefficients of 1. I can write this out that if I saw this in a textbook or wherever, I would probably see the problem simplified to look like this. Again, this is just a shortcut. And we use binomials all the time. I don't know if you've necessarily noticed in your math class how often you have one thing plus the other thing or one thing minus the other thing. Okay, so still pretty long certainly, but this is as simple as I can write it now. So what I want to do is I want to probably not do, well, I don't know. I'll do this problem to the 7th, and the great thing about you watching it on video is you can fast forward through it. But let's prove to you that this works. I have a plus b to the 7th power. If I'm using your old methods to solve this, I want you to look at how time-consuming it is. Again, if you want to solve it this way, that's okay. It's just going to take a while. So, I use my box method. This has a times b squared in it. I'm then going to have to do the box method again. Oh, forgot the squared there. A cubed 2a squared b, ab squared, a squared b, 2ab squared, b cubed, and I get out 3a squared b plus 3ab squared plus b cubed, which, by the way, notice my coefficients there are 1, 3, 3, 1. Significant because my third row was 1, 3, 3, 1. And notice that I start with a cubed, and then I could put in a little invisible b to the 0. It doesn't change the problem at all because b to the 0 is still 1. This would be b to the first, a to the first, a to the 0th. Just we usually don't write those things. So this one was a plus b cubed. So now I've got a cubed plus 3a squared b plus 3ab squared plus ab. Actually, yeah, let's ignore the a. B cubed. That's super, super sloppy. So I get for trying to draw my box first. Okay, times a plus b, and I keep going and keep going. And like I said, if you have fast forwarded at this point through the video, I do not blame you one bit. 3a squared, b squared, 3ab cubed, etc., etc. Alright, and I add them together. And remember with the box method, it just so happens our diagonals are going to be, for problems like this at least, they're going to be like terms, so I can collect them. So 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th, which notice your coefficients are 1, 4, 6, 4, 1. And on the next level, you see 1, 4, 6, 4, 1. Anyway, if you really want me to go out to the 7th, ask me, I'll do it for you. But it's getting long, I don't want to. But this pattern, it can help you figure out pretty quickly in comparison where this needs to go. So I'm going to do a couple different problems for you as examples to show you how this is going to work. And I'll recreate Pascal's triangle each time just so you can see that process as well. So I've got some problems on my other screen. I'm going to pull from those. Let's do one where I'm subtracting instead of adding. X minus y to the 3rd. Now because it's the 3rd, I want the n equals 3 row. Not the same as the 3rd row, because the first row is the 0th term. So I've got my n equals 0, n equals 1, and then add together the middle, n equals 2, 3, 3, 1, and n equals 3. So this is the row that I need. And same rule will apply here, even though I've got a negative in the middle. You just have to be a little more careful as you put this together. So I get that x minus y to the 3rd will equal, let's go ahead and put in our coefficients. And I'm going to give myself plenty of space because of what's going to come. I'm going to take the first thing to the maximum power. Now my second thing, I'm going to treat it like a negative y. I'm going to take negative y to the lowest power. And then I'm going to subtract 1 from the power on the x, add 1 to the power on the y. So I've got a squared here, and I've got a first here. I'm going to move these over slightly just because that 1 is going to be a little bit tight. And then subtract 1 from the x, add 1 to the y, subtract 1 from the x, add 1 to the y, and I can go straight to simplifying at this point. Again, can absolutely use the box method for this. Just the further you go, the more complicated it gets, the less you probably want to do that. All right, so anything that has a 0 power, remember, anything to the 0 power is 1. Anything that has a 1 coefficient, usually we don't write that. So, and then of course, if you have a negative to a odd power, that negative can be pulled out. So that's why here, instead of being plus 3, it's going to be minus 3 x squared y. And then here, the y, or the negative is squared, so it gets canceled. This one will be a plus 3x y squared. And then again, negative to a 3rd power. I'm going to see that negative get pulled out, and I'm going to get minus y to the 3rd. All without actually having to use the box problem. Again, just a shortcut. But feel free to use the box method and check my answers to check to see how I'm doing. Okay, let's do another example. Let's do, this one looks like a good problem. Let's put a coefficient inside our function, plus it's got the negative on it. So I've got n equals 4, so I need to make Pascal's triangle. This is the n equals first row, 1, 2, 1, 1, 3, 3, 1. And again, I'm getting those by adding together the two numbers above it. 1, 4, 6, 4, 1. And there we go. That's the one I need this time. You write out as much of Pascal's triangle as you need for that problem. Okay, so my problem here, I'm going to use 1, 4, 6, 4, 1. I'm going to go ahead and add these here. Of course, some things will get changed to negatives because I've got minus 1 inside the problem. I'm going to take the first thing to the maximum power, the second thing to the 0th power. And I'm going to add 1 to the second power and subtract 1 from the first power every single time. And I personally don't try to simplify anything right now. Just focus on getting the problem together using the pattern, and then come back and simplify. You'll be a lot better off if you do it that way. To the 4th power. And so I see how my power for the 2m changes every time. And I can see how the power for the negative 1 changes every time. And it's that pattern you want to focus on. And then simplify the problem using the math methods that you've learned before. So I know anything to the 0 power again is 1. I'm just going to go ahead and take care of that too. And then here I do have 2m to the 4th. So I've got to think 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So in other words, 2 to the 4th power is 16. So here I've got 1 times 16 times m to the 4th, which would just be 16m to the 4th. Let's see, 3 times 2 to the 3rd power is 8. So here I'm going to have 4 times 8, or 32, m to the 3rd. And then my negative here is to the 1st power, so that does change my sign here to a negative. Let's see here. 2 squared is going to be 4. 4 times 6 is 24. My negative here will cancel because it's being multiplied by itself, a negative number. Negative times a negative is a positive. So here I'm going to get plus 24m squared. Let's see here. 4 times 2 to the 1st power is going to give me 8. I have a negative 2 of an odd power. That means it won't cancel out the negative. I have 8m, negative 8m. And then last but not least, plus 1 times 1 times, this is 1 as well because it's to an even power, the negatives cancel out, plus 1. I get what's called that binomial expansion. Binomial because 2 terms here, expansion because I multiply it out. Okay. I will do one more. See if I see one that I really like. That's about as complicated as it gets, but I'll get one that even is just a little bit longer than that. I'll even take it out to the 5th power. Oh, this one isn't a good problem, because it also has an exponent on the inside. So, start by making Pascal's triangle. 3, 3, 1, 1, 4, 6, 4, 1. And let's see, this is n equals 0th row, n equals 1st, n equals 2nd, n equals 3rd, n equals 4th. So I need one more row to get that 5th power. That's the row I'm going to need. Alright, and since I'm going to scroll, I'm just going to write my problem again. Here, 2x to the 3rd plus 1 to the 5th. I'm going to write out my exponents. I might run out of room, but I'm going to write my exponents. I'm going to take the first thing to the max power, and I'm going to take the second thing to the minimum power. And I'm going to repeat my pattern over and over and over again. Plus, I should put pluses in here just so I don't make a mistake. And then to the 3rd power, to the 2nd power, to the 2nd power, to the 3rd power, to the 1st power, to the 1st power, and to the 0th power. Running out of room, but to the 5th power. Alright, so that pattern is what we established. That pattern is what we're going to use. And then I go through and I do need to simplify this. I can't leave it like this. So, ultimately I've got one. Well, let's go ahead and actually take care of our zeros here. Anything to the 0 power is 1. Anything to the 0 power is 1. Now this one's complicated enough. I'm actually going to simplify this in a couple steps. Break it up into as many steps as you need to. But for me personally, I think this is going to be better to just try to do one thing at a time. So I have 1 times, let's take care of 2 to the 5th and x cubed to the 5th. 2 to the 5th, let's see, so 2 squared was 4, 2 to the 3rd was 8, 2 to the 4th was 16, 2 to the 5th is 32. And our rule with multiplying the exponents, if I have x cubed to the 5th, that means I have x cubed 5 times, which I don't think I'm going to write all of them out, times x cubed times x cubed times dot dot dot. Ultimately, I think that you should see that we're going to end up with 15 x's. So this is going to be 1 times 32 x to the 15th. And then this is 1, so I don't have to worry about that. I can put times 1. Next, I'm going to do 5 times x to 2 to the 4th was 16. So times, see, I'm going to put parentheses here. I kind of like that a little bit better here. 16, and then multiply the 3 times the 4 to get x to the 12th, times 1, plus 10 times 2 to the 3rd is 8. X cubed cubed is going to be to the 9th, times 1, plus 10 2 times 2 is 4. X cubed squared is 6. 6 x's times 1. Plus 5 times 2x cubed. That's the first power, so I don't have to worry about that. Times 1. Plus 1 times 1 times 1. Alright, so getting to be kind of big and ugly, certainly. But definitely still simplifiable. I don't know if that's really a word, but we're going to use it. And I'm going to finish the problem, especially with all these ones. Let's see, 16 times 5 over here. I've got 30. Looks like it's 80. X to the 12th plus 80 x to the 9th plus 40 x to the 6th plus 10 x to the 3rd plus 1 would be our binomial expansion. This is an example of a problem I could do with the box. I personally never would want to. I would always prefer to jump to the easier way. Actually, I take that back. In a lot of things, I actually don't jump to the easier way. There's a lot of times where I think that using the tried and true method about why it works is the better way. But in this case, it's just, it gets so tedious and it's so easy to make a mistake. It's still easy to make a mistake here, but when you're using the box method, you're actually doing a lot more writing than even this, and it's going to be even easier to make a mistake. So this is going to be something that will be a helpful hint and trick for your homework. You do not have to use it. It just hopefully would help you. If you would like more examples, let me know, but hopefully this will be enough. And as you do your homework, just good luck and let me know how it goes.